This week we've been looking at the world of I/O. Now, one thing that we've already looked at so far in this class is QuickCheck. Now, QuickCheck is an I/O function. So we call it in the REPL loop, we give it some sort of property and it tests that property. However, it has to be carried out in an I/O manner. So today what we're going to do is we're going to take just using some of the tests I have from assignment 1 as a basis. We're going to write a short main method which is essentially a testing script using I/O functions, or using QuickCheck. So you can see here I've got a bunch of tests, T1 to T4, and these are calling QuickCheck on some predefined property. Now it doesn't really matter what these properties are, I just want to show you something that's quite interesting and more involved than you might expect. So you would expect that you would be able to call all of these in Haskell, in a REPL, pretty easily, and if we comment these out, you would be able to. So if I do this and I save and reload my file, everyone's happy. And if I do QuickCheck and I do Q2 test, there we go, passed 100 tests as we would expect. However, as you might have guessed, there is something odd that happens here if we try and run these I/O functions. So if I save this and reload this, you can see all of these are failing, and it says that I've got an ambiguous type variable a0 arising from a use of QuickCheck. Now, this might seem like a scary issue. It's certainly giving us a lot of very, very long-winded error messages, but it's essentially pointing to the same thing. Now, when you run these, because of parametric polymorphism, which is the type of polymorphism that Haskell employs, when we give something an abstract type of something like A to B to list of A to list of B's, whatever it happens to be, when we call that function at runtime, Haskell can then instantiate the type with an actual hard-coded type. So if your function is from int to boolean or something like that, it can then instantiate the rest of the list. And in a REPL loop, it can instantiate by defaulting to some type. I think it's something like that it defaults to. However, the I/O function does not, and that's why we're getting this ambiguous type, because all of these are polymorphic, or question 2 test and 3 and 3b test, they're all polymorphic functions. This one's not, but these three are. And because of this, Haskell is failing because it needs an actual instantiated type at runtime to know what to do. As I say, REPL, this read evaluate print loop that we go in when we call stack like this, it has default behavior. However, QuickCheck does not, and so it does not know what type to use at runtime to make these functions work. So what we're going to have to do is we're going to have to do a little bit of casting, Haskell style. So let's have a look at these functions here and see what their type is. So you can see here these are quite polymorphic. We've got a lot of different types here, and what I'm going to say is we just nick this here, and we need to instantiate this A to A with something. So what I'm going to say is, let's paste that in, and we'll cast that down to an integer type. Now, I mean, you could equivalently choose something else if you wanted, but if I save this and I bracket these or comment these out, then if I save and reload, you'll see that this now works. And I can do T2, and I get 100 pip test passed. And that's because QuickCheck now knows that this function is going to be instantiated by the int type rather than the abstract type A. So the parametric polymorphism doesn't need to worry about what's going to be instantiated at runtime because I've told it what to instantiate it with. And we're going to have to do the same to T3 and T4 here. So let's put some brackets here, and then we'll go and have a look at the type of those tests, and we can pick what to use as type signatures. So we need something that's equatable, something that's part of the ORD type class, and we need the same for question 3b. So we need a function, something of type A, list of A's, and bool. So what I would suggest you do is something like int to car. I mean, you could equivalently just cast all of these to ints. I'm just showing you that you can indeed use different types. So this A would be an int, and we'd need a list of ints. And this would go to the boolean type because it's a property. So I mean, you could equivalently just do int to int for all of these if you wanted to, if you were so inclined. That would be fine. I'm just showing you that you can do this for other types. So let's just say this one is the same. Let's do int to car. The only thing we need to worry about is making sure that these EQA and ORDB are met, and they should be by these types, because these types have orderings and are equatable, so these should be fine. and this one should be to bool as well. So let's save that. I'll reload, and hopefully I've done this right. There we go. And now I can do T3, and I can do T4. And there we go. So you can see that even though this REPL hides some of this behavior from you, this is something that can happen that can make your test fail. Especially if we tried to call these in an IO setting, as we will do in this main, we would have some issues even if we just did QuickCheck Q2 test in this main method. However, you can get around this by casting to the concrete type and sidestepping the problems that arise because of the parametric polymorphism. As I say, the REPL loop, that's this terminal here when we're in main or prelude, this has default behavior when it doesn't know what type to use, and that's why you can do something like QuickCheck Q3 test, and it will instantiate it because it knows what it should default to in the case where it doesn't know what the type is. So let's run a little simple test method or main method which allows the user to pick which test they'd like to use. So let's say do put str which test, well, if I could type anyway, would you, and we'll do put car, and this should be quite a simple function hopefully, and then we'll do x comes from get line. So now we want to check what the input is. So we're asking the user what do you want to run. It's going to be T1, T2, T3, T4, and then we'll maybe see a way how we could do more than that. So now we want to check what x is, and then we want to return based on that. So we want to say this time I'm going to use case because there's more than one thing to pattern match on. There's not just like an if it equals this, then this or this. There's 4 options, so using if statements would be a bit of a faff. So I'm going to say case x of, and we're going to say, and this will become quite repetitive. So if we do test1, that goes to T1. Now T1 is an IO action because it's a QuickCheck function. If we go down here, you can see that colon T of QuickCheck, it goes to IO bracket. So we can just call this here and it will be fine, and then we'll just do the same for the rest. And this will be quite simple and quite repetitive from here on out. And this will be T3. And then finally, we'll do T4. Now we could do something like otherwise go to main until someone chooses something to run. So let's save this, reload, and see if I've made any mistakes. So far so good. Let's call main. Which test would you like to run? Let's say I do T1. There we go. We could do that again, and we could put in something that's not, I mean, you can see there it defaults back to the recursive call, and now T4. Okay, 100 tests passed. So that's so far so good. Now what if we wanted to run them all? One thing we could do is we could just print them all out individually, if we wanted to. That would be a bit of a faff. One thing we could do is use something called sequence. Now this function has quite a funky type signature. If we look at sequence, you see it's part of the traversable type class, part of the monad type class, and you have traversable MA, and that goes to M of T of A. So it swaps around the sort of ordering of these two monadic and traversable instances. Now this is quite something quite involved, but really what we can see this as something that takes a list of IO actions and executes them. Now it'll return something a bit funky, which is an issue for us, but we'll see how to get around that. So if I say T1, T1, T2, T3, T4, then that will carry out those actions. In fact, what I can do is I can just call this in terminal for us now, and we can see that this works. So that's just executing a series of IO actions for us. So if you wanted, if you had a main method and you knew that there was like something like 7 or 8 IO actions that you wanted to happen in a row, you could use sequence like this. And because the list type is traversable, this traversable is another one of Connor's creations, you can then just call it on the list type. Now one thing you'll notice is it returns this type here. So if we do colon T, of this, you can see this is part IO brackets here. So this return type here will not be equivalent anymore. And indeed, if we try and save and reload, we'll get an issue because it's not expecting this to be of this this list type here. So what we could do, if we wanted to just hack our way around this quickly, is we could do turn like that, and I'll copy this so that we can just chuck that in quickly as we want to do. And then we'll do the same down here, and this is probably not very good style, but I'm just going to show you a quick way to fix this. And then finally, so if I save that and reload this now, because they should all be returning the same type, we shouldn't have an issue anymore. And indeed, there we go. So now if I do main and I do all, there we go. I can just, I'll just execute all the tests for me. Now you can see this being quite useful and giving you some flexibility, and that you can match off of the case statements based on the input you get, and then depending on that you can carry out some IO action, and then the sequence can allow you to chain a lot of things together. So the sequence is actually quite useful in chaining these IO operations together when we might want to just do them all. So this has just made our code a little bit more flexible and a little bit more responsive to what the user wants. You might not want to run everything, however in the case where you do, we have that behavior as well. So that's everything for today. That's everything I wanted to show you. I just wanted to mainly get you to see this is how you can sometimes, or you can get around the issues that QuickCheck causes when you come to writing an IO method. Just to reiterate, you sometimes have to cast the type to a concrete type away from your polymorphic type, so that Haskell knows what to run it, what to use at runtime. Now, it's different in the REPL loop because this has default behavior in the instance where it doesn't know what type to use, so it will worry about that for you. And the other thing is just to show you this sequence and maybe a little bit of this case statement matching to give you a little bit more tools to use when you're writing IO functions. That's everything for today though. Of course, if you have any questions about any of this, please feel free to get in touch. Thanks.